Last but not least is my number theory update. This has been really the bulk of the work in the last couple of weeks, and also it really is a reason why I didn't make as much progress with proofs, but it had to be done. So this notebook is also complete. I was going to have chapters 1, 2, 3, and 4 in here, but chapter 3 just got so thick that I've had to put chapter 4 in the new notebook. And so really this is where really number theory 2 is going to begin, even though technically some of this work was done last year. It's still in 2022. And so I have all of chapter 4 notes, which I think I've shown before. And I did do a summary of chapter 4. And I also, it's all about linear congruences and Hensel's lemma, some matrix congruent systems of equations for matrices, for congruences, so you use matrix techniques. Then of course a bunch of problems for chapter 4, and I believe I had already shown these last time. But then the new work in here is a quiz. So quiz, just going back and cleaning up all the even problems for chapter 4. And that's where I'll pick up next week with chapter 5 of Rosen's book on number theory, which is has a few typos, but I like it. I think it's a good book. I really like that. It has a lot of hard problems, a lot of really good problems. So look at that. That's the answer, I believe, for this problem. It's a very large number, mod, a very large number. So yeah, I totally get why number theory is so much fun. It's called the Queen of Mathematics. It's a great subject, and I really see myself doing number theory every quote-unquote semester of this quest. So that was chapter 4 already put into the second notebook, and then I'll go back to the finished notebook, which is chapters 1, 2, and 3. So this is the second notebook that I have finished in my math quest. Had a lot of fun. I think I've shown chapters 1 and 2 all the way to the last test, and I think at the time I also showed all the notes to chapter 3 being complete, and the fact that I did all these factorizations for Thanksgiving. But I think what's new here is the summary of chapter 3, which allows me to go back once again and look through the major concepts of the chapter. And I know at the last time I showed all the problems that I had solved or attempted. And then what's new here is the quiz. Going back and cleaning up with a bunch of even problems and some of the harder odd problems as well. And so yeah, this was a lot of fun. But there's still some weaknesses in what I've learned, and I'm going to need to come back and clean up some things in chapter 3. Chapter 3 is just a monster with so many problems. Like I said last time, it's the length of chapters 5, 6, and 7 combined. One section in chapter 3 has more problems than many chapters in the book. So I went back and just spent a lot of time working on them. Then some problems had Gaussian integers, and so I went back and I found this professor online has some really great notes. He is Neil Donaldson from the University of California, Irvine, and I found these notes to be really great. So I read them and I was like, I'm not a fan of bulking up my notebooks with printouts, but in this case I took an exception. And I'm going to continue to do that in number theory. And I may even expand and do the same for calculus and proofs. So if I find, somebody's notes that are really well written, since it's not a textbook and I want to keep them for later. The last chapter in Rosen is on Gaussian integers, but he does some early problems that he puts in. He always does that, which is fine. And so I said, I want to learn more about complex numbers, especially the Gaussian integers, which you can get factorizations. So what's a prime? A prime in the real numbers, like 3, can be like 1 plus I times 1 minus I. 1 plus. Yeah, no, that's really 2. 2 is 1. Yeah, it's 2. But either way, so it's a nice way to factorize numbers where what's a prime in the reals is actually not prime in the imaginary numbers. Yeah, I said that wrong, but I think I know what I'm talking about in some way. So for example, 1 plus 2i times 1 minus 2i is 1 minus 4 times minus 1, so it's 5. Yeah, so 5 factorizes to 1 plus 2i times 1 minus 2i. That is correct, I believe. And so, very interesting. There's more in these notes, and that's why I kept them, and I'll come back to them later, I hope. Took some notes on the notes, and then attempted the problems that Rosen had, but I don't think I did that well in solving them. So I'll have to come back to Gaussian integers. I find them interesting, but I didn't really nail them. Then did some more section 3.5 problems, which I think is the one with a lot of problems in the quiz. Yeah, so this is a lot of fun. Of course, the longest way in the world to show that 73 is a prime number. But, I wanted to do it. Why not? And then I took a test, and the test was going to be chapters 3 and 4, but I stopped at chapter 3. It was just too much. I've spent roughly the last 2 weeks working on these problems, just because there's just so much to them. And, like for example, which problem is this one? This is problem 22, where you take a number and you say, well, is this number equal to a number that could be prime plus a power of 2? And you go through, and 509 is one of them, where all the different powers of 2 plus some number, that other number is not a prime. Now when you go through, and I just did it for fun, and start with 1 and keep checking, finding all the primes, circling it with blue. I could have done this with a computer, but I did it by hand just for fun. There are a few numbers that are like 509, where every single one of the numbers that is added to that power of 2 is not a prime, it's a composite. And this particular problem will ask you, what's the one after 509? And I believe it's 599 right here. These are not primes. So anyways, and I could have kept going, but I stopped. Then I had some other problems that I tried, but they got harder. There was a couple of problems that had to do with Bertrand's conjecture or postulate, depending on which way you look at it. And I found these great notes that explain in more detail than Rosen does. And I kept them, I read them, did a bunch of binomials just for fun. So yeah, that was pretty cool. And I'll come back to this as well later on, because Bertrand's postulate links in with some other ideas in number theory. I tried these GCDs of polynomials. I had to look at the answer for one of them, and then I understood, okay, I see what you're doing. And I couldn't really do problem 30 or 32 correctly. I fumbled around, and I really didn't get it. I'll pick it up for the final. So this is definitely something that I'll pick up for the final. Hilbert numbers, also very interesting. And then proofs of the infinitude of primes. I'm sorry, problem 65 that has to do with the n plus 1 positive integers, none exceeding 2n. There's at least one in the set that divides another integer in the set. Very interesting, but it's a problem that I really couldn't solve on my own. I did find somebody's proof on the internet, and I just took notes from it. That's all I really did, just to learn of how somebody would approach a problem that I felt was difficult. And then there's a couple of problems in that section about the infinitude of primes, the infinity of primes. This is a printout from that book called Proofs from the Book. And I went through some of these. And again, more material that I'll pick up later. I'll come back to it. But I feel like it's important to stretch and to go beyond the basics. I feel like I have learned a lot about the basics of number theory as explained in these 3 chapters. So I'm satisfied for a self-learning exercise. Definitely someday I hope that I can take a course in number theory, and in which case I'll have to go through all of this material and have a professional help me learn it. I think by myself, with the internet and with answers in the back, I can do a lot, but there are clearly limitations. And this is why you do self-teaching when that's your only option, which is my only option right now, until I retire, God willing, a few years from now. But I've had a lot of fun, and here it is. That's my second notebook that I have finished in the last 5 books. About scheduling, the scheduling has changed a little because things slide in a different way when you're self-teaching and you're not bound by a semester. You don't have to go home after the end like when I was in college. So it turns out that I was able to finish what I think are 2 notebooks for number theory and calculus, and they're done. And then I'll move on to the number 2s for each one. And then in the case of proofs, it kind of slides into the next quote-unquote semester, if you will. And I'm going to finish that one at what I call semester 2 of my program. So yeah, have a lot of fun and continue to have a lot of fun, and we'll continue to plow through Rosen and Thomas and Finney and Hammock.